There's a question on arithmetic, on algebra. It came up in IFT some years ago. Let's see what this says. This one says find the coefficient of x to the power 12 in the expansion of this. Now there are multiple methods that we'll try. The first method that we'll use is the binomial expansion. Okay, so let's expand this. This will give you 1 minus 4x to the power 6 plus 6c1 is 6c2, 4c2 is 6, so 6x to the power 12 minus 4x to the power 18 plus x to the power 24 times an expansion of this 1 minus x whole to the power minus 4. We can do the binomial expansion. Now to get x to the power 12, you need to multiply this coefficient with the coefficient of x to the power 12 here. Coefficient of x to the power 12 will be minus 4 into minus 5 into minus 6 till minus 15 divided by 1 into 2 into 3 till 12. This will give us 15 into 14 into 13 divided by 1 into 2 into 3. That gives us 5. This gives us 7. So that's 35 into 13. Let's keep it as it is. We'll solve this later. Okay, then to get x to the power 12, you need to multiply quotient of x to the power 6 here with quotient of x to the power 6 here. So that will be minus 4 into minus 4 into minus 5 into minus 6 into minus 7 into minus 8 into minus 9. 6 terms to 6 terms here. 1 to 6, right? So 5 6 5 6 4 4 3 gives you 3, 2 gives you 4. So that will be minus 4 into, basically all these 6 negatives will become a positive. 7 into 12 is 84. And the last one would be coefficient of x to the power 0, that's 1 plus 6. So this will be your net effect. Okay, let's calculate this. 35 into 13 will be 350 plus 35 into 3 is 105. 350 plus 105 is 455 minus, this is 320 plus 16, 336 plus 6. So that's 330, 125. 125 will be your answer. That's the first way of doing it. Okay. Now the second way of doing it is, if you don't want to use binomial expansion, is another way also. I can write this as 1 minus x to the power 6 divided by 1 minus x whole to the power 4. Now a to the power n minus b to the power n divided by a minus b, it will expand as 1 plus x square plus x cube plus x to the power 4 plus x to the power 5 whole to the power square whole square. Okay, when you square it once, you will get 1 plus x square plus x to the power 4 plus x to the power 6 plus x to the power 8 plus x to the power 10 plus twice of each number multiplied, twice of x plus x square plus x cube plus x to the power 4 plus x to the power 5 plus the second round will be x to the power 4 plus x to the power 5 plus x to the power 6 x to the power 3, right? Plus when you multiply with x square, you'll get x to the power 5 plus x to the power, first you multiply with this, then you multiply with x, you start with x cube, right? So next one will start with x square, so x to the power 5 plus x to the power 6 plus x to the power 7, then you'll multiply with x cube, so x to the power 7 plus x to the power 8 plus x to the power 9, right? This will be, now this will result in 1 plus, if I add it up, you will get 2x plus 3x square plus 4x cube plus 5x to the power 4 plus 6x to the power 5 plus 5x to the power 6 plus 4x to the power 7 plus 3x to the power 8 plus 2x to the power 9 plus x to the power 10. Right, now you have to square this again. Now when you square this again, you are interested in coefficient of x to the power 12. How do you get x to the power 12? When you square the x to the power 6 term, that will be this. So you will get you 5 square. 5 square is 25. When you multiply x to the power 5 with x to the power 7, that will be twice of 6 into 4. Similarly, when you multiply x to the power 4 with x to the power 8, you will get x to the power 12. So that will be twice of 5 into 3. Similarly, when you multiply x to the power 3 with x to the power 9, you will get twice of 4 into 2. When you multiply x square with x to the power 10, you will get twice of 3 into 1. Right, so if you add all this, you will get 25 plus 6 4s are 24, 48. You'll get 15 2s are 30. This you'll get 8 2s are 16, and this you get 6. Right, 16 plus 6 is 22, 22 plus 30 is 52, 52 plus 48 is 100, 100 plus 25 is 125. This also gives you 125, same as the previous one. Either ways, whichever one is comfortable, right? We just expanded in either in terms of squares, or we use the binomial expansion. Two ways of solving the same question. That finishes this one.